Okay, inverse functions, again, we talked about it before. To find the inverse function, especially because this one's in function notation, it's sometimes beneficial to turn this into a y value. So I'm just going to move the equation over to the right here. Y is equal to all the same other x value variables. A lot of times they'll represent this as please find the f prime, f at prime of x, and that will be how they'll represent this. Instead of actually writing the words find the inverse function, they might symbolically represent it with just the prime value, and all they're saying is find the inverse. All that means, like we talked about, is take your x and y values, invert them, in other words, replace them with each other. So in this equation, our inverse will be x is equal to, so we've replaced the y value here, and now we're going to replace these two x values with the letter or the variable y. This one over y plus 8. Now, at first glance, I struggled to figure out how we were going to isolate this. But what we did discover is one way we can do it is we can take the denominator here and multiply the equation by the denominator. So multiply by y plus 8, and over here, y plus 8. Okay? What that does on the right side is these two essentially cancel out, or they create a 1 value, which leaves the right side at being just 2y minus 1. And over here, we end up with y plus 8 times the letter x. I got a bit confused last time, but a way we can do this is we can now just use distributive property, and we'll use our x here and distribute it to both of the values. We'll end up with y at x, so y times x plus 8x is equal to 2y. What's tricky here is the goal is to actually isolate for the letter y. And we happen to have, the underline in blue, we happen to have two y's. So we're going to move 2y to the left side of the equation. We want to put them together, and what we're going to do is try to use a little bit of factoring to isolate for the y. So we bring over 2y, and we'll end up with y at x, subtract 2y, plus 8x is equal to, and we'll leave the negative 1 over there. What's great now is we have two terms beside each other, and they both have the y in. We can use common factoring. So we'll common factor y out of these two terms, and we'll be left with x minus 2, and we still have plus 8x is equal to negative 1. This is good now because we've turned two terms with the letter y into one term. So that's really important for what we needed to do. What we now will do is, again, try to isolate for that y, so we'll slowly start moving things to the other side. We'll take this 8x and move it over. That will leave the left side as y times x minus 2 is equal to negative 1 minus 8x. Then what we can do from there, because this is multiplication, we can divide both sides by x minus 2 and x minus 2. Now on the left side of the equation, these end up canceling out. Turn that off. Those two end up canceling out, and when I say cancel out, they just create a 1 value. So y is equal to, I'll move the variable in front, it's just a common thing to do, negative 8x minus 1, and we have x minus 2 in this case. So this is now the inverse function. We could graphically prove this. I think I can actually bring in the browser right in here. Bring the browser in. We'll go to Desmos. I think I can shrink it a little. There we go. There's some space for us. Okay. What we'll do is we'll put in the original function. Y is equal to, and I'll put in a set of brackets, 2x minus 1. 2x minus 1 divided by x plus 8. X plus 8. So this is our rational function. We'll zoom out a bit. Okay. And an inverse function is flipped on, like we said, a y equals x. Think of this being the axis. We'll turn it green. So it's going to be something that's flipped on this. So this is going to be a little tricky to visualize. We'll put in our new function here. Y is equal to negative 8 x minus 1. And that's going to be divided by x minus 2. It's 2. There we go. And that looks like it's been flipped on that y-axis there, okay? So we've done a rational function with the inverse. We've done the inverse of a rational function in this case.